should be pretty easy. Anyways, so remember, like, just your picture of your flower, roots are on bottom, powers are on top. So remember that radicals are the same thing as fractional exponents. So this is only one base, right? So you only have to write base. You'll write the base. It's base x. And then you know it's a fractional exponent. So roots go on bottom. So it's a cube root. So the 3 goes on bottom, 7 goes on top. So just make sure you're careful, because on the multiple choice part of the test, I have made sure to like do little things like flip those two. You know what I mean? So don't just like just be really careful when you're like selecting the correct answer. Because I flipped those and stuff like that. Okay, so with this one, because there's 2 bases, you've got to be really careful. So because there's 2 bases and they're both under the root and they're both raised to the 4th power, just write the base and make sure you write both of the bases in parentheses, right? There's 2 bases, so it needs parentheses because they're both under the root and both raised to the 4th power. So it's a cube root again to the 4th, yeah.
So you only do that if it was in parentheses?
Yeah, yeah. Otherwise, well, yeah, because otherwise, I mean, it could look a couple different ways, but 2 is definitely under the root, right? So there's going to be parentheses at some point, but is the power also raised to both is your question. You know what I mean? So we know it's definitely going to, this is going to be there, right? With parentheses, but then does the 4 just stay inside? No, because it's both of them. Does that make sense? If it was just one of them, then that would be a 1 and the 4 would be inside. Good question. So with this one, there's only one base, so it's pretty easy, right? We just write it base x, and then it's a fractional exponent, it's a square root, right? And then 3rd power. So, I mean, they're not going to be super hard. This is about how hard it's going to be. So just be careful, like I said, when selecting your answer, because it is multiple choice. I have switched things, you know. Okay, we all good with that? Okay, so then you have to go the other way, write each expression in radical form. So 3 and x are both raised to the 2/3 power. So they're both under the same root, which is a cube root. And then it's both 3 and x, both raised to the 2nd power, right? So you might see it written like this, but also if it's multiple choice, notice this is the same thing. The cube root of 3x, both raised to the 2nd power. Does that make sense? They're just written a little bit differently. Or they might not have those, they might go like this. Parentheses, the cube root of 3x without parentheses raised to the 2nd power. Because they're both under the root, right? And they're both raised to the 2nd power. So it just depends on the multiple choice test. Okay, so let's practice this one. They're both under the root, right? So I'm going to do that first. It's a 4th root of 4 and x, and then depending on the multiple choice problem, they could either go like this, they're both raised to the 1st power, right? But then think about it. Anything raised to the 1st power is just itself. So they would just write it as this, the 4th root of 4x. Does that make sense? So if there is a 1st power, they're not going to write it. So like you could write it yourself like that, and then look at your answer choices and say, well, which one is it? Does everybody get what I'm saying with that? Okay. So then this one, it's the 5th root, and then they might go a to the 3rd, which is most likely what they do, but this would also be considered correct. The 5th root of a to the 3rd power.
There's such thing as negative roots?
No, good question. There's not. Okay, are you guys good with those? So the parentheses don't throw you off? Okay. Okay, simplify using properties of exponents. So this part will be multiple choice on the test, but then you'll have to pick whatever answer you pick. You've got to rewrite it in radical form. So there'll be 2 parts to this. The first part's multiple choice. So we're just multiplying all this stuff, right? So we could reorder it. 3 times 9 times x to the 4th times x to the 4/5. So I'm just reordering it, and then you just go ahead and simplify it. So 3 times 9 is 27. Don't add those. I have specifically made those errors when putting the multiple choice problems. You don't add numbers, right?
No.
So 3 times 9 is 27. And then I have specifically made the error on purpose that when you multiply the same base, you multiply the exponents. That's not true, when you multiply the same base, you add your exponents. So I have made that error just so that if people that do that are going to see that correct answer, you know what I mean? And it's actually incorrect. So you'll add, and you'll just do it in your calculator, 4 plus 4/5,
It's 24 over 5.
and it's 24 over 5. So you guys all know how to change it back to a fraction. So x to the 24 over 5. Okay, so then from there, you would click or push that answer, whatever, fill in that answer. But then don't forget, because you'll miss half the problem if you don't read the second part, which says write your answer in radical form. So now we're going to write it in radical form. 27 is just being multiplied to this, right?
Yes.
So we don't put that under the root, right? No. So we have 27 times by the 5th root. Make sure you put your 5 in there. Tuck it in there nice and pretty. The 5th root of x to the 24th power. Okay. Now if you got that far, I'd give you full points. I'd probably give you a bonus point if you actually went through and simplified that, because can't we break that down into and then pull out groups of 5? Does that make sense? So I'm going to give anybody a bonus point that goes as far as to simplify it. You get what I'm saying? So you could write out 24 x's. This is a really big example. It probably won't be that big. Do you get what I'm saying? Circle groups of 5, and then they come out, right? Do you want me to keep going with that?
With the parentheses that we've been doing.
So like, so like if we wanted to, there would be 24 x's, right? That's a lot of x's. But let's say it was like, let's say it was x to the 12. That's better. 1, 2, 3, like instead of x to the 24, let's say it was the 5th root of x to the 12th. Let's say that's what it was. That's a little bit better. So we know that that means we're doing the 5th root of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then you pull out groups of 5 since it's a 5th root. So 1, 2, 3, 4, 5. Now that can leave the house, right? 1, 2, 3, 4, 5. So those can leave the house. So we had 2 x's come out, right? And then left underneath was 2 x's, right? So we have the 5th root of x squared. So we pulled out 2 x's, that's x squared, the 5th root, and then x times x was left underneath, which is x squared, and then we had our 27. Do you get what I'm saying? Like, so try to push yourself. Just try simplifying it. It's not like, you know what I mean? If you do that and get it wrong, I'm not going to mark it wrong. Because if you have this answer, that's what I'm looking for, but if you go one step further, you could earn a bonus point. Okay. Because I don't think on an end of level they would stop here. You know what I mean? They would want you to be able to simplify. Okay. So factor each completely. This is a huge part of the test, being able to factor. The first thing with factoring, this is the most important, because especially you were making this area, you were making the same error. You weren't factoring out things that we could from the beginning. So let's always make sure we do that first. So let's look at these problems here. We have 1, 2, 3, 4 terms. Anytime you have 4 terms, just know you're factoring by grouping. Does that make sense? Group the first 2, group the second 2, including the sign, and then factor out the greatest thing in common in each group. If you're not factoring out the greatest thing, you're not going to get it right. So we have a 2x squared, right? Yeah. So 2x squared. Now divide each thing by what you pulled out carefully, and then we're writing it in parentheses. So 10 divided by 2 is 5. X cubed divided by x squared is x. Are you guys okay with that? Then negative 14 divided by 2 is negative 7. X squared divided by x squared is 1. So negative 7 times 1 is just negative 7. Are we all good with that? Moving on to this next group, the greatest thing in common. You guys see it?
3.
Yeah, 3. And then we want to make sure we pull out negative 3, right? Yeah, good. So I pull out negative 3. So then let's divide each thing. Now careful, make sure, a lot of people on this part, when they pull out a negative, forget to divide by negative 3. So negative 15 divided by negative 3 is positive 5x. But positive 21 divided by negative 3 is negative 7. So then we check our safe haven. Make sure you're really careful, because if your safe haven has a plus and a minus sign, you can't pull it out, right? So and you would get it wrong if you didn't have the minus sign. So just like make sure you're pulling out what you need to. Check your safe haven, and it's good. So we factor out our safe haven, 5x minus 7. So So don't just magically make it disappear. It's still there. You pulled it out, so it divided out. So then left was 2x squared minus 3. Okay, is everybody good with that? Okay, so there's going to be 2 factoring by grouping problems. So let's do one more right here. Okay, so we have 5m cubed plus 3m squared minus 3m minus 18. Now, once again, the reason you know you're going to factor by grouping is there's 1, 2, 3, 4 terms. Throw parentheses around the first 2, around the second 2, including the sign. Yeah.
And so, like, if you get a problem where they can have something factored out, how would you solve that problem?
So you're saying, like, if all of these had a 3 in common?
Yeah.
You'd factor, well, you can always factor by grouping without pulling out something in common, if there's 4 terms. So, but if there was, you could pull out the 3, right?
Mm-hmm.
And then you could still factor by grouping.
Oh.
Yeah, good question. So in this group, because technically, like in the end, if that was the case, one of these would have something that pulled out further. Does that make sense? Okay. All right, so looking at this one, we have an m squared in common, right? Don't let these ones throw you off. Like, a lot of times people are like, well, 5 and 3, nothing goes in. Well, that's fine. Then move on. So we have an m squared in common. So we pull out m squared, write it right there, divide each thing by what you pull out to see what's left. So we have a 5m left, and then plus 3. And then in this one, the greatest thing in common, even greater than 4, and 6. Yeah. Yeah. Now here's what always helps me. Like, let's say you didn't know. We know that 30 needs to become 5, right? Yeah. So like that always helps me. That's kind of my cheat sheet. I'm like, 30 needs to become 5, so I take 30 and divide it by this thing, and then I know I'm going to probably be pulling out -6. Does that make sense?
But
Yeah. But then if it didn't come out of this, then you would know, okay, I can't do that, right?
Yeah.
But then you would say, well, then what happened?
Yeah.
Does that make sense? Did I maybe not factor out the greatest common factor here? Okay, so I divide 30 by 5, I get 6. And because of the negative, I know I'm going to try to pull out -6. And then we'll check our safe haven to make sure that's for sure what we're doing. Divide each thing by -6. -30 divided by -6, positive 5, right? 5m. And then -18 divided by -6 is positive 3. So we did do this correctly. So we pull out our safe haven, 5m plus 3. Write it on the outside, it divides out. Left is m squared minus 6. And then we would check to make sure it doesn't factor further, but with these ones, you'll be good. Okay. But actually, now that I look back at the test, you might always check these to make sure that something doesn't factor out more. Does that make sense? So, like, let's say your answer, that wasn't there. Like, well, did something more pull out? Because what if this was, let's change this. What if it was 15n plus 3? Could I have pulled out another 3 out of this?
Yes.
Do you get what I'm saying? So just, okay, so we're all good with that? Okay, awesome. Okay, so don't let these ones throw you off. Like, these should be not too bad. So it says factor each completely. Before we do anything, we always factor out what's in common. This one has 2 terms. What's in common right now?
V.
So we pull out a v, divide each thing by what you pulled out, that leaves us with v plus 9, right?
Yes.
That doesn't factor any further, right? V doesn't, v must 9. So there's going to be one that easy on there.
I don't know why, but I always like leave it complicated. I'm always like, oh, that's a 1.
Right. Yeah. So, yeah, a lot of students do that. So just be careful. Yeah.
I'm just like, why are you doing it?
I know, huh? Right, well, it just takes practice. Okay, next one. Do not start doing the quadratic thing in here. Like, a lot of times people start doing what multiplies to be a times c and adds up to be b too soon. Too soon. This isn't quadratic, it's cubic. So, what's in common first? So, we have to pull out an x first. That's really the most seen mistake on the test. This, it just says factor, like on the test, we're just factoring it, but like with factoring, the first thing we always do is pull out like something in common if possible. So that one had an x in common, right? So now left inside, divide each thing by x, is 2x squared minus 5x's, and then minus 3. But then from there, you would look, okay, can it factor further? This piece can't. This piece, though, is quadratic, degree 2, right? And we know that we can factor quadratic. So we have to do what multiplies to be a times c, right?
6.
What multiplies to be, and we got to be really careful because it's actually negative 6, right? What multiplies to be negative 6 and adds up to be negative 5. Are you following me on what I'm doing here? So 1 times 6 and 3 times 5. So you got to make sure you get the right one. Wouldn't negative 5 have to both of these be negative?
You said
Oh, sorry, negative 3 and 2. Wouldn't both of those have to be negative?
yes.
And that wouldn't work, right? Because that's not negative 6. Do you get what I'm saying?
Yes.
So we would say those don't work. But what about 1 and 6? Yes, that could add up to be negative 5, but the 6 would need to be negative, right? And then that works in both cases. Now we cannot quick factor in this one because our a value is 2. So we drop and break. So can I erase this so I have some room? Okay. So remember that we chose positive 1, negative 6. So then we drop and break. So drop down the end term, so 2x squared. Drop down negative 3. And then we break down the middle term and we're rewriting it as our 2 factors. Order doesn't matter. So I'm going to go negative 1x, so negative x, and then,
Plus 6.
oh wait, wasn't it positive?
Positive x.
Okay, so it's positive x and then minus
6.
6x, right? Are we all good with that? You're sure?
Yes.
Okay, so then we group the first 2, we group the second 2. In this group, in common is an x, right?
Yes.
So left is 2x plus, don't say nothing, 1. And then in this one, there's a negative 3 in common, right? We always call it negative if the negative's in front. So we're pulling out negative 3. Left is 2x plus 1. So our safe haven's good, so we pull that out. So we're pulling out 2x plus 1. Therefore, divide it out, but you gotta write it. And then left is x minus 3. And then don't forget, because that's going to be one of the answers right there. But that's not our answer. We forgot that we originally factored out an x, right?
So you put your words.
Right. So that would be our final answer. Is everybody good with that? Okay, so don't get too hasty and start what multiplies to be a times c too soon. Okay, let's do another.
What would happen if you did?
Some people have come out with the right answer because they broke it down correctly because they dropped x cubed down, they rewrote these two things as x squared, so then it happened to come out okay. But I'm like, you got lucky there. I don't know. You know? So. Okay, so with this one, 2x squared minus 128. Anything in common in the beginning?
2.
Good. Let's pull out a 2. So then divide each thing by what you pulled out. Is everybody following me? So x squared, 60, what is that? 128 divided by 2, 64. Okay, x squared minus 64. Okay, are we all good? Now we have to check, does it factor further? This one's pretty hard. 2 obviously doesn't factor further, but does this. So we'll do, it is quadratic, right? It's degree 2. So this is when we always do what multiplies to be a times c, so negative 6. What multiplies to be 1 times negative 64, right?
Yes.
And adds up to be 0. There's nothing, no vx, right? Are you guys following me? You're sure? Okay. So 8 times 8, right?
Yes.
And one of them would have to be negative. So 8 and negative 8. So those work. Can we quick factor? Yep. Look, our a value is 1. So it's going to factor to be those two things. So you write your binomial. You put in your x, right? And then one of them is going to be positive 8. And one of them is going to be negative 8.
Why does that work?
Because, like, I mean, if you double distribute this and combine like terms you get here, and it only works if the a value is 1. I don't know exactly why it works, to be honest. I don't know exactly why it works. but don't forget your 2 in your final answer. Okay, are we all good with that one? Okay. All right, next one, 3. You're going to have 2 like this, where they're simply just quadratic, and there's nothing in common in the beginning. So I don't know how you can factor a quadratic. 3a squared minus 15a minus 150. Yeah, they do all have a 3 in common, so I'm going to factor that out. Let's say you didn't, though, you'd be okay, because you'll look at your final answers, right? And always make sure there's nothing more you could pull out. So if you didn't factor out a 3 in the beginning, it's going to come out the right answer, but you just got to factor your final answers further. But I'm going to choose to factor out a 3, because then it's quick factoring. So I see that all of those divide by 3, so I pull out a 3. Make sure, like, this is one of the common mistakes on the test, is students will say, they all divide by 3. So they go divide by 3, divide by 3, divide by 3, and they never put the 3 out here. They just divide everything by 3 and it, like, disappeared. But that doesn't happen, right? Do you get what I'm saying? That really is one of the most common errors. So you divide it by 3, so it's on the outside of your parentheses. So then you have a squared minus 5a, right? Oops, not minus 15. So... okay. So minus 5a and then minus 50. So minus 50. Okay, so then from there you look and say, does it factor further? Obviously 3 doesn't, but this is quadratic and it does factor further. So we do what multiplies to be a times c, which is 1 times negative 50, what multiplies to be negative 50, and adds up to be negative 5. Now you're going to get it wrong if you don't put the negatives. So you've got to be careful. That's like another thing. People will write 55 or like a negative 50 and a positive 5. Your factors will be different depending on the negative.
So it's negative 10 and 5.
Negative 10 times 5. Very good. Negative 10 plus 5. So check it. It works in both boxes. Now because our a value is 1, positive 1, we can quick factor. So it factors to be a binomial. You put in your value, your a value in the front, right? Minus 10 plus 5, and then we won't forget that we originally factored out of 30. So no questions on that. Okay, so there's going to be 2 just like that. Now if you would have done it the other way, you would have been fine. You would have come out with, like, for example, if you wouldn't have factored out the 3 in the beginning, you did 3 times negative 150, you have that, and what adds up to be negative 15. You would have got down to here and been okay. You would have ended up with the answer 3a minus 30 times by a plus 5. So then you just know, like, oh, I need to factor a 3 out of that, right? Do you get what I'm saying? Okay. Does that make sense? Okay. Awesome. Okay, so that's with factoring. That's all I'm doing with factoring. Get those right. Then, guys, couldn't you check your answers by redistributing, remultiplying things back through, combining like terms, and checking your answers? Because multiplication is the exact opposite of factoring. Okay, let's do these. Simplify each product. These are probably the easier ones of the test. It's just, these aren't multiple choice, so there's a lot of room for error. So we have 3x minus 2 times x minus 3. We'll double distribute. So we'll have 3x squared minus 9x. Don't make any sign errors, guys. I hate to have you miss these because you made a sign error. Negative 2 times x is negative 2x. And negative 2 times negative 3 is positive 6. So just be really careful with signs. Combine like terms. 3x squared, negative 9 minus 2 more. Careful, negative 11x, right? Plus 6. Okay. With this one, you'll rewrite it, right? Negative 2x minus 1 times negative 2x minus 1. And there's a lot of negatives in here. I did that. I made it an advanced problem on the test on purpose. So you have to be really careful with distributing negatives. Negative 2x times negative 2x. Oh, this is where the most common error comes in, is the first one, right? Good. 4x squared. A lot of people forgot to put the x squared part.
Oh, I thought people put negative.
Right. A lot of people put negative, and a lot of people just write x. Negative 2x times negative 1, positive 2x, right? Negative 1 times negative 2x is positive 2x's. Negative 1 times negative 1 is positive 1. Combine like terms, 4x squared plus 4x's plus 1. Okay. can't combine those, right? Okay, we're all good with those? Okay, now there will be one where you have to triple distribute. So draw your arrows if necessary as you go so you don't miss anything. 2x times 3x squared. Very careful. It's 6x cubed, right? 2x times negative 2x. Negative 4x squared. 2x times positive 1 is positive 2x. Is everybody good with that? Now distribute positive 2 through. Positive 2 times 3x squared is positive 6x squared, right? Positive 2 times negative 2x is negative 4x's. Positive 2 times positive 1. Notice I don't draw them in as I go. I mean before I go. I do it as I go so I don't miss anything. Positive 2 times positive 1 is plus 2. Then combine like terms and make sure you write your final answer in standard form. Highest degree to lowest degree. Okay. Now degree is this, right? This thing. So even if this was negative, we would have still wrote it first, right? Okay. So 6x cubed, no other x cubes. I cross them out as I go so I don't miss anything. Negative 4x squared plus 6x squared is positive 2x squared. I cross them out as I go. Positive 2x minus 4x's is positive negative 2x's plus 2. Now highest degree, the lowest degree. So we have it in standard form. Because this instruction specifically will say, and write in standard form. So if you don't do that, I have to mark partially wrong. Okay. Okay, any questions? Yeah.
When you have a problem that you like take away, like if they all have an m in common, and you like take away, and
Are you talking factoring or, okay?
in the middle of this square to 2, you still like.
Let me see what you're looking at. Oh, okay. No, it's n. So now it's quadratic, right? So you'll do what multiplies b times c and after 3b. The end of the term will have something.
But I thought you were doing that square.
No, it's not the middle term, it's the leading term squared. So you're good. Does that make sense? Good question. Okay, so classify a polynomial. This is the part of the test that is not multiple choice. So hopefully you can do it. So first things first with classifying is to write it in standard form, make sure all like terms are combined. So this one's in standard form, right? All like terms are combined. So then you look at the highest degree, and then number of terms is the second name, right? So what's the name for fourth degree? It's not fourth degree. Quart. 4 quarts in a gallon. So it's quartic. And it has 3 terms, so it's a trinomial. So there's monomial, there's a constant, monomial, binomial, that's 2, trinomial is 3, then there's polynomial of 4 terms, polynomial of 5 terms, nothing after that. With the degrees, there's linear, well there's constant, linear, constant, linear, quadratic, cubic, quartic, quintic, 6 degree. Yeah.
So will you have like the options of or
Nope. You just have to really just know it. Yeah. So before you classify it, combine like terms. So with this one, x cubed plus 3x cubed is 4x cubed, right? Positive 5x plus 7x. 12 x's. Okay, so we combined all like terms. Now you name it by highest degree and by number of terms. So the first name is from the highest degree. So it's cubic. And it's 2 terms, which is binomial. So you might want to look over that paper a couple times before, you know what I mean? And then let's look at this one, because this is probably, it says simplify first and then name it. So this is we're taking this polynomial, subtract this polynomial. So with subtraction, be really careful because you will write a -1 in there, right? Distribute it through. So -1 times x squared is -x squared. negative 1 times negative 4x is plus 4x. This is going to change the whole answer. So this one you could potentially get completely wrong. Negative 1 times positive 2 is negative 2. So I changed all my signs. That's the first step. Then combine like terms. So we have, carefully, negative 3x squared plus negative x squared. Negative 4x squared, right? Positive 2x's plus 4x's is plus 6x's. Positive 2 minus 2 is 0, right? And this one? So then you name it by highest degree and number of terms. So highest degree is quadratic, right? Quadratic. And it's a binomial. Questions? Okay, this is one that actually wasn't on the test review, but is on the test. So this is a good one to go over. Here we go. So, I'm going to ask you, what is the degree of the polynomial? So we always determine degree off the highest degree, right? So look at this one. What's my highest degree? 3, right? So you would just call it degree 3. So this one's degree 3. Degree 3. Like, I'm not having you name it, I'm just saying what's the degree. So it's degree 3, and this one happened to be a trinomial, but because it was 3 terms, not because of the 3 up here. This is called cubic, right? Does that make sense? But degree 3 is what I'm looking for. Is everybody good with that? Okay, this next one's probably the trickier one. Because isn't x squared, y squared being multiplied? And we can't add those, right? Because they're not like bases, but we still classify this as degree 4 because they're being multiplied. Does that make sense? These ones are being added. So we don't say 3 plus 2 plus 1. Do you get them? So because these are being multiplied, this is considered degree 4. I added them up. I didn't multiply them. Do you understand that? Okay, because that wasn't a very good example. What if this was 3 and 5? 3 and 2. This would be degree 5. Does that make sense, everybody? Okay. So don't let that throw you off with something like this. Are those being multiplied? No. So we only go off the highest degree, so this one would be considered degree 3. Does that make sense, everybody? You're sure?
Yes.
Okay. Addition, go off the highest degree. Multiplication, you will add them up, even if you can't, you know? Okay. Okay, this is the one that is on the test that's going to require some actual thinking. So let's see if you guys can think of how you would do it. So it says, the given expression represents area. Find the side lengths of the square. So this is the area. We need to know the side lengths, right? How did you get the area?
You would times them together.
Length times width, right? So it's something multiplied to something equals that.
So you'd have to take that apart.
Perfect. So we would just break this apart into its factors. And how do we do that? Factoring. Yeah. So, well, we wouldn't divide it by 2 because then we would come out with, if we divide it by 2, it's going to not help us too much. But we're going to break it into 2 pieces, right? 2 equal pieces. So we break it down by factoring, don't we? Can't we? Isn't factoring 2 things multiply to be that?
Yeah.
So let's factor it. So is it quadratic?
Yes.
It's degree 2, so we always do what multiplies to be a times c. Right, what multiplies to be positive 4 and adds up to be... So do you see, Braylon, how this is the x squared, the middle term? It's the leading term's quadratic. Yeah. Does that make sense? Okay. So it adds up to be negative 4, right? 2 times 2?
Yes,
but they both have to be negative, right? Which makes sense. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So it works in both cases. Can we quick factor this one? Yes, but I'm going to do it the long way because on the test you're going to have to long factor. So we drop and break, right? So we drop down x squared, we drop down positive 4, then we break down the middle term and rewrite it as negative 2x, negative 2x, right? Then you group the first 2 terms, group the second 2 terms. What's the greatest thing in common there? X, so left is x minus 2. Factor out a negative 2, right? Left is x minus 2, right?
Yes.
So you factor out x minus 2. since it's in common, and then left is x minus 2. Now look, so this side's x minus 2, right? And this side's x minus 2? Because length times width will equal that. So when it says what are the side lengths of the square, you'll just draw it in. X minus 2 times x minus 2. Does that make sense? Which makes sense, right?
Which means the picture technically is wrong.
My picture doesn't look very drawn to scale, does it?
Yeah.
Because squares would be equal, right? Yeah. The one on the text is actually drawn to scale. I just drew that one by hand, so yeah. Is everybody good with that? You sure? Don't let this one throw you off. Factor. Then you know what multiplies to be in, right? Okay. We're all good then? That's everything that's on the test. Make sure you three push yourselves to really do the bonus problems, because there's going to be some bonus problems on there that I think you should probably be able to figure out. Okay, awesome. Thanks for coming. And if you have any questions on the review, I could do some. Okay, so we know that we can't just square that, right? We have to rewrite it. So we rewrite it as 3a plus b times 3a plus b. And then we're going to double distribute. So you'll do very carefully here, 3a times 3a
It's 9a
9a squared. 3a times b,
is 3ab.
3ab's, right? So positive 3ab's. And then positive b times 3a, 3ab's, very good. And then positive b times positive b is plus b squared. So then you'll combine like terms, right? So no like terms with that, right? No other a squareds. And then no other b squared, so we'll have plus b squared. But then aren't these like terms? Aren't they exactly the same?
Yes.
So make sure, so this is like 3 apples plus 3 apples. The apples part doesn't change, right? That's just 6 apples. So 3 plus 3 is 6, so we have plus 6 ABs. Does that make sense? So this would be our final answer. So is there any others like that one you want me to do?
No, I guess.
That one's just good enough? Okay. Any others off the review?